All right, guys, we're on the back side of day 2 notes for Unit 8, and in number 8 says that a baseball diamond is in the shape of a square. We know a square has all equal sides, and it also has 4 right angles. Okay. It has sides of length 90, so all of them are 90. And they want you to find the distance from home plate to second base in simplest form. So let's say home plate is in this corner here. This is where the batter stands and the catcher and the ump. And then this would be first base. This would be second base. And here would be third base. Okay. They want us to find the distance from home plate to second base. So if you notice, that's the diagonal of the square, but the diagonal of the square is also the hypotenuse of a right triangle. So if we look and take a look at just this right triangle here, when we're asked to go ahead and solve for this side, okay, we can go ahead and pull that triangle out of there if you want to make things a little bit simpler, but you have 90 there, and this is what we're looking for. All right, so this is another Pythagorean theorem. So a squared plus b squared equals c squared. Notice the question mark is across from the right angle, so that's our c. So 90s go in for a and b. And 90 squared and 90 squared make, it's a big number. So what do we got? 16,200 equals c squared. Okay? And we'll go ahead and take the square root of both sides. And that's going to leave us with c equaling, and that is not a nice number when you type it in your calculator. And if you notice in directions, they did ask for simplest radical form. So we're going to have to find the largest perfect square that goes into 16,200. And that seems like a big task, right? But what happens is that you added 2 perfect squares together here. 90 squared is 8,100. And that is the largest perfect square that actually goes in. So you can use that as a little trick. And because you added 2 of them together, it goes in 2 times. Okay. And we'll go back and we'll circle our perfect. Square root of 8,100 is 90. So we end up with 90 square root of 2. And I taught you this little trick back in, our quadrilateral unit, that if you know the side of a square, the diagonal of the square ends up being the same exact number times a radical 2. And so if you remember that little trick, you can skip all this work and go right to your answer of 90 radical 2, knowing that your sides of your square were 90. Okay? All right, let's take a look at number 9. It says in simplest radical form, find the diagonal of a rectangle with a side of 4 and 6 meters. So this time we have a rectangle, so we cannot use our trick. Okay? But in our rectangle, we have sides of 4 and 6. So those 2 would be 4, these 2 would be 6, since opposite sides in a rectangle are equal. And they want us to find the length of the diagonal. And remember that in a rectangle, we have right angles. So we can use the same Pythagorean theorem, okay, on our triangle here. And we're looking for our hypotenuse. So if we take our Pythagorean theorem, and we plug in 4 and 6 for our A and our B, we'll be able to solve for the hypotenuse, okay, which is really the diagonal of the rectangle. 4 squared plus 6 squared, typed in your calculator, added together, give you 52. And because they said in simplest radical form up here in the directions, okay, when we solve for C, and 52 isn't perfect, we'll break it up into a perfect. Okay, the largest perfect, don't forget, which is 4. The other number ends up being 13. When we circle our perfect, we end up with our diagonal being 2 square root of 13. Okay, let's take a look at number 10. It says in simplest radical form again, find the diagonal of a square with a side measuring 7. So do you see how they said 7? We can use our trick. All right, so I'll show you the long way. I'll show you the short way. Again, they want you to find the length of the diagonal. All right, so taking a look at our square here, okay, the diagonal of the square is actually the hypotenuse of that right triangle. I already know the answer if you remember from number 8. Okay, you can skip all the work that I'm going to show you. If you don't remember the trick, this is how you would do it. Write down your Pythagorean theorem. Put in your two side lengths, okay, and leave C for the hypotenuse. 7 squared plus 7 squared is 98, equal to C squared. To solve for C, we square root both sides. And 98 is not perfect, so we would break it up into a perfect, the largest perfect that goes into 98. And if you remember from up here, 7 squared is 49, and 49 is the largest perfect that goes into 98. And because you added 2 of them together, it goes in twice. And the square root of 49 ends up being 7 square root of 2. And so if you remembered the trick, you take the side, you multiply by radical 2, and you get 7 radical 2, and you could have skipped all the work I showed you in red. Okay, one last one. Number 11, it says if the diagonal of a square measures 10. So this one's a little bit different. They didn't say the side of the square measures 10. They said that the length of the diagonal measures 10. Okay? And they want to know what is the measure of the side of the square. Okay? And it doesn't matter which side of the square you find, okay, because they're all equal. So this one's a little bit backwards. So this one we can't take a trick for the shortcut of the problem, all right? But we can still use the Pythagorean theorem. We can sub in the same variable for A and B, and 10 has to be the hypotenuse this time. Okay? Do a little algebra. X squared plus x squared is actually 2x squared, and 10 squared is 100. Okay? We're going to divide by 2, and that way x squared comes out to equal 50. Okay? We're going to go ahead and square root both sides. Those will cancel, and because they said simplest, did they say simplest radical form? They didn't. So technically, we could actually leave it as the square root of 50. But since we're practicing simplifying radicals, 50 is not perfect, and the largest perfect that goes into it is 25, and the other number is 2. And then we can go ahead and circle our perfect and say that our answer is 5 square root of 2. Okay. All right. I will see you guys on the next day of notes.